Hey guys, thanks again for watching the second video. Here we'll go ahead and show you how to set up Repetier Host and calibrate the HE3D printer. In the previous video I showed you how to set up Repetier firmware on the K280 3D printer. So here you're going to just plug in your printer to the wall and also plug in the USB cord. And after launching Repetier Host, which you should have installed by now, just go ahead and connect to your 3D printer. On the top left corner there's a button that you click there. Next, under the manual control tab, click the home button, and that's going to actually home your printer, and your carriage is going to be approximately 60 millimeters away from the end stops after homing completes. Next, in the G-code field on the top right corner, you want to go ahead and type in M321. This is going to actually deactivate the auto bed leveling feature on the printer. And then once you've homed the printer and you've deactivated auto bed leveling, you want to use a 2-foot long piece of aluminum rod. It doesn't have to be aluminum, it can be any stick that you have laying around, as long as it's about 1/4 inch thick and fits between the belts and the towers. As you see in the video here, I am using that rod and placing it on one of my tower ends here, and then jogging the z-axis down very slowly so that the top of the carriage touches the top of the rod. Then you want to click that red button that I highlighted. This is essentially going to disable your stepper motors, and you can go ahead and stick the 2-foot long aluminum rod on the top plastic piece that holds the towers in place. And while holding the rod in with one hand, use your other hand and just press down on the carriage piece so that it actually touches the top of the aluminum rod. Carefully remove the aluminum rod. And then repeat this step with the remaining towers. So while moving the towers, just make sure that the side that you moved earlier does not actually get moved, because again your stepper motors are all disabled at this stage. Once you've done this, remove the aluminum rod, go back to Repetier, and in this case type in a G132 space S1 and then hit the send button. What your printer is going to do is going to home itself, and it's essentially going to go ahead and measure the end stop offset. So if you actually look in the log area in Repetier, you'll see that there are 3 tower values showing you the offset, the end stop offsets. If you go back to the website and scroll all the way down, again the website is crunchyroll.com, scroll all the way down to the section that shows tower and bed calibration, and so that article just lists the tutorial. You want to go ahead and click the link to the Escher G-code file, and Dropbox is going to open, allowing you to download the file. Just click the download button and save the file locally to your computer in the folder that you know. In my case, I'm just placing it into that HE3D folder that I created earlier, and then go ahead and click the save button. Once you've downloaded that file, you no longer need Dropbox. Next, we're going to go ahead and click the Escher Calculator link, and it's going to take you to this wizard here. It's made by, I'm not sure exactly who made that, but thank you, whoever made it. That's not my tool. And what you want to do is scroll down to this section where it says firmware type, choose Repetier as the firmware type, and we're going to go ahead and fill in the information here, just like you see on screen. So because this is a HE3D 3D printer, I'm just going to set the diagonal rod length to 340. The delta radius is going to be 190, and then the home height is going to be 555, just like we set up in the firmware earlier. The printable bed radius I'm going to set to 100, simply because the bed that comes with the printer, the glass bed that comes with the printer, is a little smaller, so we want to make sure that the end stop and the BL touch stay within a workable area. And then go ahead and click the suggested coordinates button. Back in Repetier, go ahead and click the load button, then load that G-code file that you downloaded earlier. And I'm just going to go ahead and adjust the log area here and then clear it, because when you run this code, it's going to generate and probe the points, or at least probe the bed height at the coordinates that were generated by the Escher calculator. So if I switch screens earlier too fast, just go ahead and look at the backtrack to that section of the video and pause it. You'll see that the coordinates that are generated by the Escher calculator are the same ones that I've programmed the G code to measure the bed at. So as this G code is executing, if you look into the Repetier log space, you'll see that it's generating a whole bunch of data there. And in this case, it's essentially just taking the height measurements at different areas. The area I'm pointing to right now in the bottom right corner is essentially just to let you know to move your bed clips in positions where it's going to prevent the pen head from colliding with the clips. So just make sure that you're careful about that. When the measurements are done, you'll see that in the log area, there's a whole bunch of lines. You want to pay attention to the lines that start with the Z probe keyword, and there's going to be 7 of those lines. So just copy the Z probe value from that area, or just look at it and manually go back to the Escher calculator and type in the actual value. So in this case, the first one is 22.0.85, and the next one is going to be 22.419, and so forth. So I'm not going to read every single thing out, but I'm just going to speed up this section of the video so that you can see the actual values that I'm typing here. Now, after you have typed all of these values in there, again, there's going to be seven of them. You want to go ahead and take the 6th value. So in this case, you want to take 20.575 and you want to subtract it from all the other values in that nozzle height error column. So I'm just showing you here, I'm taking the first one, 22.85, and subtracting 20.575 from there. That gives you 2.275. And you just repeat this step for the remaining points in the nozzle height error column. And the reason that we're doing this is just normalizing the Z probe values. After that, click the calculate button in the Escher calculator, and you're going to get a whole bunch of new values like the new end stop corrections and diagonal rod length and deltas. So what we're going to do is essentially copy the new values in Repetier, and this is directly accessing your Pender EEPROM. So you don't need to run Arduino IDE anymore. Just go to this menu area in Repetier, and then the tower X, Y, and Z end stop offsets correlate to the new end stop correction values in the Escher calculator. And the horizontal radius, again, you copy the same value, is the same as the delta radius in the Escher calculator. And the new home height obviously is equal to the Z max length. So you want to just copy those values in there. And then we're going to copy the new tower position angle corrections from the Escher calculator into the delta radius A, B, and C in Repetier. After that, go ahead and click OK in Repetier, and we're just going to go ahead and clear the logs again because this is an iterative process. And you want to just run that same G code file again. So just, if you still have it loaded in your workspace, just go ahead and click the print button, and it's going to execute again. Your printer is essentially just going to home itself again, and it's going to go down just like it did before and take a whole bunch of points and then report the heights at those specific coordinates. You'll notice that every time you run through this process, it'll get more and more accurate. So you should be getting the Z values that you're reading now should be getting closer and closer to each other. So once the code is done running, we're going to go back to the Escher calculator again. Make sure you keep the Escher calculator webpage open every time you do this, and then just click this button on the bottom corner that says copy to initial parameters. This is going to copy your new generated parameters to the top of the calculator, and under the suggested probe points area, you're just going to copy the new Z probe values that you just ran the second time into the nozzle height error in the Escher calculator. And once you copy and paste or type these values in the nozzle height error column, we're going to do the exact same thing we just did earlier. We're going to take the value from the point number 6, which is going to end up being a large value right now. So we're going to take that value and we're going to subtract it from all 7 points. So again, whatever nozzle height error you initially measure in Repetier, you take that, you subtract it from all the other 7 values here. So you're going to take 21.244, subtract it from all of the 7 values in the Escher calculator, and then click calculate. And this is going to generate a new set of end stop correction values, home height, delta radii, and new tower position angle corrections. And we do the same thing again. You go to Repetier, config, EEPROM, and then you scroll down to the appropriate variable location and type in the new values. Okay, so the only thing that's left to type in are the delta radii A, B, and C. And again, A correlates to X, B correlates to Y, and C correlates to Z in the Escher calculator. And again, you could just pause the video to take a look at what variables and what values I'm typing and what they correlate to in the Escher calculator. They're just not called the same thing in both programs. After this, go ahead and click OK to save your settings in your printer EEPROM. And you can run this procedure as many times as you want. Usually 2 to 3 times is okay. And just make sure you click copy initial parameters in the Escher calculator after each iteration, because that way the new values that you calculate are based off of your previous measurements. So here, go back to Repetier, clear the logs, and then this time go to the config print settings, and under the printer tab, you want to make sure that the same value that you typed in for Zmax length in the EEPROM menu, that you type that in Zmin here. And then you also go in the printer shape, and for the printer height, you're going to type that same Zmax value. Again, it needs to be the same one that's in your firmware, just so that Repetier has the same dimensions that you have in firmware. Now we're going to go to Thingiverse, type in circle, and search for a part. I'm just going to pick this circle from Yahoo Japan. I'm not sure who that is, but thank you for the model. And just go down to the thing files area, click the circle file, save the file to your computer. It's going to be an STL file. And if you've ever used Repetier, it's pretty simple. We're just going to go to the load menu area here, and we're going to select that circle.stl file and open it, load it on the workspace. And then we're going to go to the slicer area. I use the Cura engine slicer that comes with the Repetier, and I find it's okay to get started with. So I'm just going to go and click on the configuration button here, just to show you what my settings are like for the HE3D printer. I mostly left all the defaults alone, and the thing that I really changed is under the G code tab. So the start G code, because I'm using dual extrusion, mix 2-in 1-out extruder, and I changed the start code and the end G code sequence here. And all it's really doing is just shutting the fan off, heating up the heat bed nozzle, and shutting them and turning them back on when needed. So pause the video, take a look at those settings if you want, and then go ahead and slice the part. And under the manual control tab, I'm going to go ahead and start the print, and you'll see what happens. I mean, at this stage, your printer should just go down and start printing. If your nozzle collides with the print bed, you've done one wrong thing. You've probably did not subtract the values in the Escher calculator like you were supposed to do. So make sure you've done that and rerun that calibration test again. If your nozzle is too high off the bed, or it's printing like mine is doing right now, it's printing, it's touching the bed, but I don't think it's perfectly even. I'm going to try to zoom in a little bit so that you can see what's happening. But it's fairly close, fairly leveled, but I don't think it's perfectly leveled. So for anyone who's been watching the video so far, you'll notice that my print bed has some yellow adjustment bed leveling springs on it. If your HE3D printer didn't come with one, you can just rerun the calibration test again. But if you didn't, and you printed these adjustment pieces, now would be the good time for you to do to better adjust your bed manually, mechanically, using the paper method. And here you just take a little piece of paper, lower your nozzle so it's as close to the bed as you can get it without necessarily jamming that piece of paper. And what you do is you wiggle the piece of paper back and forth as you lower the nozzle down at very small increments, like 100 microns at a time, or 0.01, until the piece of paper gets stuck. So here, I'm just moving that piece of paper. You can see it's stuck now. And I'm just going to lift my nozzle up just a little bit so that that piece of paper moves with some resistance, but doesn't just slide right out, right? So at this stage, we can then go ahead and just, when you're happy with the resistance that you feel on the piece of paper, don't move your printer. Just write down the current Z value that you see there, and then subtract that from your existing Z value if you need to do that. What I did is I did not need to adjust my nozzle height. So what I essentially did is I just started printing, and I printed a big circular piece. You can see it's starting to make the part perimeter right now. And I just watched for where the nozzle started to kind of get a little too close to the bed, and it almost scratched it. So you just kind of have to adjust those little yellow levers, I'd say, or levers. Somebody correct me if I'm wrong. Just twist the little adjustment caps on there. I've posted the link to those little Thingiverse 3D printed parts. So if you want to go ahead and actually click and print yours, it's all in the article, all in sequential order. So you can just go ahead and follow the steps there, and you should be able to get to this stage. So mine is pretty leveled as it is now. I like it. I might need to lift the right side up a little bit more, but I think it's pretty much there.